Hello, Calculus and Vectors class. This is the last lesson for Unit 4. We've learned all of our rules. Now we're going to focus on applications of derivatives. So we're going to take derivatives and then apply them to real-world situations. Before we do that, we're going to try one more differentiation problem, just because if you notice, when we combine them together, they can be a little bit messy. So we're going to try one particularly messy example together, just so you can see exactly how we would go about solving it. So we have this function, I of x, which is f of g of h of x. So we have a composition inside a composition of functions. So obviously, we can already tell it's going to probably look a little weird when we get to it. So we have our three inside functions, f and g of h, outlined at the side. And hopefully you're okay with the composition of functions and you're able to write that out. In case you're not, I put it up here, just in case you want to see what it looks like when you have the whole function all together. But we're not really too focused on that. We want to focus on the solution. So to do that, we need to figure out how we're going about that. So let's take a look at this problem, and you'll notice we have composition inside composition. So chain rule is probably going to factor in. So the trick is we just have to start by picking our outside and our inside function. There's a couple ways we could do this. I'm going to recommend making this our dividing line. So taking f and making f our outside function, and then g of h of x going to be our inside function. So I've shown on the second line, and that looks like I of x is equal to f of g of h of x. That's the derivative of the outside function with the inside function inside it. And then we multiply by the derivative of the inside function, which is g of h of x. So basic chain rule just looks a little different because we have a few functions nested inside each other, like those Russian nesting dolls. And then the next step, we're just going to take that second half of that, and we're going to expand that out. So g of h of x primed is just going to change over, and it's going to become g prime of h of x times h of x, h prime of x. Just basic chain rule again, just to help simplify that second part. Let me fix that really quick. H prime of x. Now, to help us out, I've done a bit of the legwork already. I've taken all of our functions, all the ones that we need here, and I've already differentiated them. F prime of x is going to become 1 over x, negative 1 over x squared, which we just do by converting it into a negative exponent and using our power rule. G prime of x is going to be 4x minus 6. H prime of x, we just convert h of x into an exponent, so x to the 2/3, and then we just use our power rule to differentiate, and it becomes 2/3 x to the negative 1/3, which we rewrite as a root. And then we take g of h of x and g prime of h of x, and they're all outlined down there. So hopefully those are not too difficult to riddle out. If you're not sure, then just come and ask me, but hopefully you're okay with that. But I want to focus on the simplifying process because that's where this one gets really messy. So for this one, now that we have our chain rule and side chain rule outlined, let's start plugging in the information we have here. So first thing is f prime of x. So f prime of x is negative 1 over x squared. It's not x squared, it's going to be g of h of x. So that was 2 cube root x times cube root of x minus 3, all squared. So f prime of g of h of x is all taken care of. The next part is g prime of h of x. We solved that at the side. That was 4 cubed root x minus 6. And lastly, we just need h prime of x, which was 1 over 3 cube root x squared. So next step, let's take all that. We know we like to have everything looking like one big fraction, so let's take all the numerators, put them together, all the denominators, multiply them together, and let's see how that looks. So that's going to be -1 times 4 cube root of x minus 6 times 1, which we know just goes away. And then that's all over 2 cube root x times cube root x minus 3, all in square brackets and squared, times 3 cube root of x squared. Now that we have that, let's try and simplify a bit. In the numerator, we can take that and we can multiply with that -1. So let's do that. So that's going to be -4 cube root x, and then -1 times -6 is +6. And in the denominator, let's see, that exponent 2 is probably going to make things a little bit messy, so let's use our rainbow rule. Let's expand everything out using that exponent 2. So the exponent 2 is going to apply, just in case you're not sure what I'm talking about here, there's that exponent 2, and we're going to apply it to the 2, the cube root x, and to this bracket here. And let's simplify that a bit. Okay, so 2 squared is going to be 4. Cube root x squared is going to be cube root of x squared. And then let's just keep this in the brackets right now. Let's see. I have a feeling it's probably not going to help us too much to expand that out, so let's not worry about it. So 3 cube root of x squared. And we're running out of room a little bit, so I apologize, by the way. I know that I did not leave you very much room here. So let's make a little more room here, and I'll finish off the solution. Would it be very handy if you could do this in your pencil and paper notes? Wouldn't that be awesome? Okay, so now that we've done that, there's not too much we can do with the numerator. We can reverse it because we like to have the positive number up front. So let's do 6 minus 4 cube root x. And we could actually even common factor that. Let's do that actually. So let's make that 2 times 3 minus 2 cube root x. And then on the bottom, let's kind of simplify this a bit. Let's combine all the things that we can combine. We're just multiplying a whole bunch of stuff together. So I see a 4 and a 3. Let's multiply those together, and we'll get a 12. And then we have 2 cube root of x squareds. So we have cube root of x squared times cube root of x squared, which is just the same thing as saying x to the 2/3 times x to the 2/3, or x to the 4/3, which is the same as saying cube root of x to the 4. So we take the cube root of x squared, cube root of x squared from the second term on the bottom and the last term, and those become cube root of x to the 4. And then we just have that exponent 2 expression, cube root of x minus 3 squared. And last thing, the only thing we can do here is just reduce the fraction. So let's do that really quickly. 2 over 12 becomes 1 over 6. And then we just rewrite everything else out as is. So 1 times everything in the bracket is going to go away. We're left with 3 minus 2 cube root of x all over 6 cube root of x to the 4 times cube root of x minus 3 squared. And that's pretty much it for this problem. So, like I said, this is a particularly messy problem, but unfortunately sometimes in calculus things tend to get a little bit messy. So hopefully that helps out a little bit. Usually for the stuff in this class, I won't be that mean, but just kind of be prepared for that, because as you go more complicated in your university level calculus career, you might see things like that you need to be able to work through. So it'll take some time and some practice, but it will get easier.